Graph the following absolute value inequality. So first, we're going to graph this just like we would a regular equation. So we're going to use transformations and a little bit of plugging in x values to graph this. So first I see that there's a -1 on the inside and a -5 on the outside. So this -1 is going to move my vertex, which is that bottom point or the highest point. It's going to move it to the right 1 unit, and this -5 on the outside is going to move it to the down 5 units. So normally it's here at 0, 0. So I'm going to move right 1 unit and down 5 units. So my new vertex is here at 1, -5. Now we need to find points on the right of the vertex and the left of the vertex. So I'm just going to choose x is equal to 2. And I'm going to substitute that in and find its y value. And we're going to pretend this is an equal sign just to find our points. So if I substitute a 2, you get 2 times the absolute value of 2 minus 1 minus 5. So 2 minus 1 makes 1, and the absolute value of 1 is 1. So this is 2 times 1 minus 5. Well, 2 times 1 makes 2, minus 5 makes -3. So I have another point at 2, -3. Now let's find one on the left side. So now let's choose x equals 0 because it's on the left of my vertex, and we're going to substitute that in. So y equals 2 times the absolute value of 0 minus 1 minus 5. 0 minus 1 makes -1, and the absolute value of -1 is a +1. 2 times 1 makes 2, minus 5 makes -3. So I have another point at 0, -3. So now that we can kind of see our V shape, let's talk about the types of symbols in the line. So this is the same as linear absolute values. If you have a less than symbol or a greater than symbol, you're going to have a dashed line because you can't include the line as a solution. If you have a less than or equal to or a greater than or equal to, you're going to have a solid line because the line is allowed as a solution. So we have a less than symbol. So that means our V is actually going to be a dashed V, not a solid V. The last part of graphing these absolute value inequalities is there's going to be a shaded area because there's more than just 1 or 2 solutions to this. There's infinite. So I'm either going to shade inside my V here, or I'm going to shade outside the V here. So the way we figure out where to shade is we're going to choose a test point. It doesn't matter which coordinate you choose, we're going to choose a test point and substitute it and see if it's true. Well, the easiest point to test is 0, 0. So we're going to test 0, 0. That means my x is equal to 0 and so is my y. So we're going to substitute those values and see if we get a true statement. So we have y less than, and our y is now 0. 0 less than 2 times the absolute value of 0 minus 1, because x is also 0, minus 5. And now we evaluate. So 0 less than 2 times, so we have 0 minus 1 makes -1, and the absolute value of -1 is a +1, minus 5. So we have 0 less than, 2 times 1 makes 2, 2 minus 5 is -3. So is 0 less than -3? Well, that's not true. 0 is greater than -3. So since our test point came out false, that means we're going to shade without the point. So our test point was 0, 0, and 0, 0 falls inside, so we're going to shade on the other side, which is on the outside. So this is the graph of this absolute value inequality. Let's do one more. Graph the following absolute value inequality. So we're going to graph this the same way we graphed the other one. We're going to use our shifts, our translations, to graph our vertex. So I see I'm moving left 3 and up 2. So that means I'm going to move left 3 and up 2. So here's my new vertex. And now I need to find coordinate points on the left and the right. So I'm going to go ahead and do that quickly and then reveal the graph. Okay. So here are the 2 values that we picked. I picked x equals -4 for the left side, x equals -2 for the right side, and I got a coordinate of -4, 1 and -2, 1, and the graph is resulted here. So now we have to figure out what kind of line we're going to be using, solid or dashed. So that is the symbol, the inequality, and we have a greater than or equal to. So because it has that equal to, that means we're going to use a solid line this time. So we're going to draw a solid line through my points. best you can. Then we're going to pick a test point to figure out where we're going to shade. And again, it doesn't matter which test point you pick as long as it's either on the inside or the outside of the absolute value. So I'm actually going to go with 0, 0 one more time because 0, 0 is the easiest point to substitute because zeros are nice and pretty. So we're going to use x as 0 and the y as 0. So our y is actually a 0 greater than or equal to negative of the absolute value of x, which is a 0, plus 3 plus 2. So 0 greater than or equal to negative times, so 0 plus 3 is 3, and the absolute value of 3 is 3, plus 2. So 0 greater than or equal to, that makes this negative 3 plus 2, and negative 3 plus 2 makes positive 1. So is 0 greater than or equal to 1? No, that is false, so that means we're going to shade inside because we want the other side of this point. 0, 0 was not a solution, so it cannot be in our shade. And that's graphing absolute value inequalities.